Imagine a world where every thought, every calculation, every pixel flickered into existence at a snail's pace.
That's life without RAM, the unsung hero of your digital experience.
RAM, or random access memory, is the temporary storage space where your computer stores data it needs to access quickly.
It's the difference between a computer that crawls and one that flies.
But this speed comes at a price density. To build faster RAM, we need to cram more and more transistors onto tiny silicon wafers.
And as we approach the limits of what's physically possible, engineers have had to devise some truly ingenious techniques.
Join me as we explore the fascinating world of RAM manufacturing, where cutting-edge technology and environmental responsibility go hand in hand. Creating a RAM chip is like painting a masterpiece, but instead of brushes, we use light. This light is not just any light, it's a highly controlled beam that allows us to achieve incredible precision.
Specifically, we use a process called photolithography to etch intricate patterns onto silicon wafers. This process involves coating the wafer with a light-sensitive material called photoresist.
These patterns define the transistors, which are the building blocks of modern electronics. The tiny switches that store information as ones and zeros, but there's a catch. The smaller we want to make these transistors, the more challenging it becomes.
Light, like any wave, has a wavelength. The wavelength of the light we use directly impacts the size of the features we can create. And just like you can't use a giant paintbrush to create fine details, we can't use light with a large wavelength to create incredibly small transistors. This limitation is a fundamental challenge in semiconductor manufacturing. We need to find ways to work around this limitation to continue pushing the boundaries of what's possible.
This is where multi-patterning comes in. It's a sophisticated technique that allows us to overcome the wavelength limitation.
Imagine using a stencil to create a pattern. Now, imagine using multiple stencils, each slightly offset, to create even finer details. Multi-patterning is like using multiple stencils, each slightly offset, to create even finer details. This technique allows us to achieve a level of precision that would be impossible with a single stencil. By carefully aligning each stencil, we can create incredibly small and intricate patterns on the silicon wafer.
By exposing the silicon wafer to light multiple times, each time with a different stencil, we can create features smaller than what would be possible with a single exposure. This multi-exposure process is a key innovation in modern semiconductor manufacturing. We can create features smaller than what would be possible with a single exposure. This allows us to continue shrinking the size of transistors and packing more of them into each chip.
It's a bit like a high-tech game of Tetris where precision and ingenuity are key. Each piece must fit perfectly to create the final product. The ingenuity and precision required in this process are what make modern electronics possible. Without these advanced techniques, we wouldn't have the powerful and compact devices we rely on today.
In a world constantly demanding more data storage, we need to think beyond traditional limitations.
Just as skyscrapers maximize space by building upwards, 3D stacking allows us to increase RAM density by layering memory cells vertically.
Imagine a stack of pancakes, each representing a layer of memory cells. That's the basic idea behind 3D stacking.
By connecting these layers with tiny electrical pathways called through-silicon vias, or TSVs, we create a dense three-dimensional network of memory cells.
This technique comes with its own set of challenges. Aligning these layers with nanometer precision is like stacking playing cards on a windy day. It requires incredible precision and control.
But the rewards are worth it. 3D stacking allows us to cram more memory into the same footprint, leading to faster, more powerful devices.
At the heart of every transistor lies a gate, a tiny component that controls the flow of electricity.
Think of it like a faucet that turns the flow of water on and off.
In traditional transistors, the gate was made of silicon dioxide, a material that works well but has its limitations.
As transistors shrink, the silicon dioxide gate starts to leak electricity like a leaky faucet wasting water.
To solve this problem, engineers turned to materials with higher dielectric constants, aptly named high-K materials.
These materials act like a tighter seal on the faucet, preventing leakage and improving transistor performance.
High-K metal gates, as they're called, allow us to build smaller, more efficient transistors.
This means faster processing speeds, lower power consumption, and longer battery life for your devices.
It's a win-win situation for both performance and efficiency. As we push the boundaries of miniaturization, we need tools that can keep up. Enter extreme ultraviolet or EUV lithography, a revolutionary technology that uses a very specific wavelength of light, extreme ultraviolet light, to create even smaller features on silicon wafers.
Think of it like using a finer-tipped pen to draw even more intricate details. EUV lithography allows us to create transistors with features just a few nanometers in size, a feat unimaginable just a few years ago.
This means we can pack more transistors into the same area, leading to denser, faster, and more efficient RAM. EUV lithography is a game-changer for the semiconductor industry, enabling us to continue Moore's law, the observation that the number of transistors on a chip doubles approximately every 2 years.
With EUV lithography, the future of RAM is brighter and smaller than ever before.
Manufacturing RAM is only half the battle. The journey from raw materials to a finished product is intricate and demanding. Before a single module ships out, it must undergo rigorous testing to ensure it meets the highest standards of quality and reliability. This is crucial because even the smallest defect can lead to significant performance issues.
Think of it like a boot camp for RAM, where only the strongest survive. Each module is put through a series of intense tests designed to push it to its limits. One of the most important tests is burn-in testing. This process is essential for identifying any latent defects that might not be immediately apparent. Modules are subjected to high temperatures and voltages, pushing them to their limits to weed out any potential defects. This ensures that the modules can handle extreme conditions without failing.
It's a grueling test, but it ensures that only the most robust modules make it to market. This rigorous process is what sets high-quality RAM apart from the rest. Next comes speed testing, where modules are run through their paces at various frequencies to assess their performance. This step is crucial for ensuring that the RAM can handle different workloads efficiently.
Think of it like a track and field event for RAM, where speed and agility are paramount. Each module must demonstrate its ability to perform under various conditions. Finally, modules are sorted based on their performance in a process called binning. This step categorizes the RAM into different performance tiers. This ensures that each module meets the specifications advertised, guaranteeing consistent performance for consumers. Quality assurance is not just a step, it's a commitment to excellence.
Manufacturing RAM requires a significant amount of resources, but the industry is increasingly focused on minimizing its environmental impact.
From water conservation to energy efficiency, RAM manufacturers are implementing sustainable practices throughout the supply chain. Water is essential in chip manufacturing, used for cleaning and etching wafers. Advanced filtration systems allow manufacturers to recycle a significant portion of this water, reducing their reliance on freshwater sources.
Some facilities even boast near zero discharge, meaning they recycle almost all the water they use. Chemical management is another critical aspect of environmental responsibility. Strict protocols are in place for handling, storing, and disposing of chemicals used in the manufacturing process, minimizing the risk of pollution and protecting worker safety.
And let's not forget energy efficiency. From clean rooms to manufacturing equipment, companies are constantly innovating to reduce their energy consumption, lowering their carbon footprint and contributing to a more sustainable future.
The journey of a RAM module from raw silicon to your device is a fascinating tale of transformation. It begins with the intricate patterns etched by multi-patterning, a process that requires extreme precision and advanced technology. These patterns form the foundation of the RAM's architecture. As the silicon wafers undergo various stages of refinement, they are meticulously crafted into towering structures through 3D stacking. Each step in the manufacturing process is a marvel of engineering and precision, ensuring that every byte of data is handled with utmost care.
But it's not just about pushing the boundaries of technology. The RAM industry is constantly innovating, finding new ways to enhance performance and efficiency. Alongside these technological advancements, there is a strong commitment to environmental responsibility. The industry is implementing sustainable practices that minimize its impact on the planet. This includes using eco-friendly materials, reducing waste, and ensuring that the manufacturing processes are as green as possible.
From water conservation to energy efficiency, RAM manufacturers are adopting practices that conserve resources and reduce emissions. These efforts are paving the way toward a greener future for electronics manufacturing, where sustainability and innovation go hand in hand.
So the next time you power up your computer or smartphone, remember the incredible journey of the RAM inside it. Take a moment to appreciate the wonders of RAM. It's a universe of innovation packed into every byte, a testament to our insatiable thirst for faster, more efficient technology. As technology continues to evolve at a rapid pace, the role of RAM becomes even more crucial. It is the backbone of modern computing, enabling everything from simple tasks to complex computations.
And as we continue to push the limits of what's possible, the advancements in RAM technology will play a pivotal role in shaping the future. One thing is certain, the future of RAM is bright, fast, and sustainable. With each innovation, we move closer to a world where technology and sustainability coexist harmoniously.